Okay, so for Woods, for your problems here, remember we talked about similar figures and the ratios of sides. If we were looking for missing sides on these figures, the ratio from one side to the corresponding side on the other figure is constant. But in this first one, we're looking for a missing area. So we have that ratio of length of 4 to 7. How do we use that to find a ratio of areas? What do we have to do that 4 to 7 first? Can't be reduced, but there it is. It's a ratio of lengths right now. We have to square it to make it a ratio of areas. So that's going to become what? Careful, 4. There you go. 16 over 49. So that's the ratio we use to compare the areas. Then what? The 20 goes with the 16. There you go. You could flip it and multiply by the 20, or we could use the proportion and cross multiply and divide. What do we get? That sounds about right. Not that I don't trust you, but there it is. 61 1/4 is correct. So that is inches, what? Squared. Okay. The second one, we have a ratio of lengths there of what? Well, ratio of lengths would be 6 to 10. We can reduce that if we want to what? Careful. 3 over 5. There you go. 3 over 5. Now, this is a ratio of volumes. What are we going to do with that? Cube it. So that 3/5 has to be cubed. What's that become? There we go. 27 over 125. Well, lucky, good guess at least. Then what? Okay, 72 over x. Cross multiply and divide, what do you get? 333 1/3. Yeah, works for me. Did you guys concur? Cross multiply and divide, of course, right? And what are the units on that? Inches cubed, yes. Any questions? Okay. I'd put that one up there because that's the type of problem that was about 4 weeks ago, and a lot of people forget that one for the test. So I'm going to give you guys your test and then. So for the first one here, half-life. Remember, there's 2 possible formulas. We can either use 1/2 to the power of t over half-life, or we can use 2 to the negative power of t over half-life. Which one did you guys use? The half? Okay. So how does the formula go? The amount that we have is equal to 500, the initial amount, times 1/2 the power of. Now our time is 3 days and our half-life is 9 hours. We've got a problem there, don't we? Convert it to hours. So 3 days is 72 hours over 9. Perfect. And remember, all that is indicating is the number of half-lives. 72 hours over 9 would be how many half-lives? 8. So it's been cut in half 8 times. What did that calculate out to be? 1.95 grams left. Always do a quick double check on that. That sounds about right. $1.95, yeah. Any questions? Okay. How for the second one, do you guys remember the formula for interest, for exponential growth? Okay, so our balance is equal to the principal, which is 2,000. Okay. %6. How are we going to write it? 0.06, 600ths. Yep. We've got to adjust that though with what? How does that play into it? Not times, but divided by 4. What gets multiplied by 4 is the years to find the number of periods, right? 4 periods a year for 8 years means you have how many periods? 32. Good. And that's just 4 times 8. That's 4 times t. K times t was the lingo. So what did that come up with for a balance? That seems a little large. Let's take a look. You didn't divide by 4? Okay. Anybody else come up with anything? Anybody want to take a guess? Remember, we mentioned briefly that rule of thumb, 72 divided by your interest rate is the number of years it takes to double. So 72 divided by 6% would be 12 years, right? So it should take about 12 years to double. So this isn't going to double in 8 years. So it's got to be less than 4,000. 3220.65. Remember, we talked about those benchmarks, those estimates, and that was one of those little benchmarks of that rule of 72. You know it can't double in 8 years at that interest rate. So you know it has to be less than 4,000. Okay. You guys have any questions on the stuff you guys did yesterday for homework? You want